Greetings and welcome to IIT's Food Science and Nutrition Science Seminar Series. And it's my pleasure today to introduce Urvi Bharat Shah, who's a PhD candidate in food science at North Carolina State University and is working with cold plasma technology for egg washing with quality and safety. So Urvi got inspired when she was pursuing her undergraduate studies, and I believe it was in biotech engineering, when she realized that there's this thing called innovative technologies in food, and she really got passionate about pursuing this particular angle of food production. I've known Urvi for a few years, and it's funny, I actually met her at a conference where I had talked to her online a few times, but she came in to listen to some presentation and they had texted me saying she was in the room. So I was looking out for her. And there she was helping a bunch of people with their technologies and helping them find their way around different rooms because they just started this new system. And right then I realized she not only was interested in technology, but she also really got into it, learned about it, and was always ready to teach other people, which, by the way, is a very important thing when we are looking at adopting technologies, but making sure that it also works. So today we are going to have Urvi speak to us about what is your topic, Urvi? I think it's safety and egg safety, something to do about eggs. She's going to talk to us about it. But what I would like you to pay attention to is that she is a student in another program and she's talking to you because she never misses a chance to talk about technology. Take it away, Urvi.
Thank you very much, Dr. Shelke. That was very kind of you. Very good introduction about me. Thank you very much. I'm going to start sharing the screen here. Can you see my desktop right now?
Yes.
All right. And now the presentation. So the topic is food safety needs in the egg industry. And my outline for today is I'm going to talk a little bit about eggs, structure of eggs later during the presentation, why salmonella and how does it come into picture with eggs, the egg washing steps in United States and what is the global debate. And I'm going to introduce to you new technology called plasma and plasma activated water, and end with some conclusions and challenges about new technology. If there are any questions, feel free to put them in the chat. And I have not kept my presentation very long, so we will have a time to discuss also later after the presentation about the Q&A. And I have got a great introduction, but just a little bit about myself, how I got curious about eggs is I started knowing more about eggs while I was working at Roseacre Farms, developing novel egg-based products and performing shelf life and challenge studies on those. And even today, I'm daily learning something new about eggs because they are complicated. My role at NC State is geared towards enhancing safety of shell eggs. So let's wake up everyone, and I would like to you all to guess which would be the leading egg producing country you think. You can unmute yourself and answer. I'm not looking at the chat right now. So if you want to type, feel free to type. Any guesses?
China?
Oh, that's correct. Awesome.
Oh,
So it's China, followed by India, then Indonesia, and then USA, and so on. So in USA, as per a survey in 2017, egg was considered second most protein source. In 1977, eggs got bad press, and there was actually reduction in consumption to prevent cholesterol increase and heart disease. After 40 years, it was scientifically proven that nutrients in eggs actually reduce the risk of inflammation associated with chronic disease. Now, if you're dyeing your eggs during Easter, I hope you're doing so after hard boiling them. And these are some examples of natural dyes that can be used if you're going to consume the eggs after dyeing. And Encyclopedia has really cool stuff and really cool list of ingredients to dye your eggs. But the safety part here is if you hard boil them, then you would be able to eliminate the pathogen that is present inside the shell egg, and that is salmonella. So let's talk a little bit more about salmonella. As you may know, it is gram-negative organism. The ideal conditions would be warm weather and unrefrigerated foods, and hence we refrigerate eggs. It's a facultative anaerobe, and there are more than 2,000 serotypes of Salmonella, but Salmonella enteritis is most commonly associated with eggs. Salmonella can be present on the outside or the inside of shell eggs, like yolk or egg whites. Even if your egg is clean looking and no dirt and there are no cracks, salmonella could still be present in the inside. What I'm trying to say is there is no guarantee of salmonella free eggs. And in United States, shell eggs are the major source of salmonella related cases. UP population, that is young, elderly, pregnant, and immunosuppressed people, are more susceptible to infections, and it can even cause death. So I'm not going to bore you with the numbers, but let's keep in mind the FDA egg safety rule came into picture in 2009, which was designed to have preventive measures during production of eggs in poultry houses and during refrigeration and storage and transportation of eggs. But even then, when you look at these numbers between 2009 and 2015, the salmonella egg category is one of the top categories, resulting in outbreak associated illnesses. And after 2015, we saw some major recalls of eggs from Good Earth Egg Company, Roseacre Farms, and Gravel Ridge Farms. So, this is my first flag indicating we probably need some new technology to reduce these recalls associated with eggs and salmonella. But how does the salmonella enter the shell eggs? There are two pathways. So, one is vertical transmission, where the hens can pick up the contaminated food or dust from the environment. So, this is through oral consumption. And now the salmonella infects the digestive tract and hence infects the ovaries. So, before even the egg is laid out, salmonella is already present inside of the shell egg. That's called vertical. And the other one is horizontal transmission, where after the egg is laid out, it can come into contact with contaminated environmental sources like contaminated feces. So now, in horizontal case, the salmonella is present on the outside of the surface of shell egg, and it can actually enter inside the shell egg later on. So if you're not familiar, check your refrigerators today and check the egg cartons that you have. See if your egg carton has the safe handling instruction. That is all it says is to prevent illness from bacteria, keep eggs refrigerated and cook them thoroughly. So this is an FDA requirement, and in United States, shell eggs have not been treated to destroy salmonella, and they must carry the safe handling statement. But we do have egg washing. So what I'm just going to quickly go through these steps of egg washing. This is a conveyor belt, and these are rollers that can rotate the eggs, and there is a nozzle mechanism for spraying. So eggs come in contact with detergent like potassium hydroxide for a few seconds and sanitizers like chlorine or quat. And the last step would be drying to avoid any residues on the outside of the shell egg. The important part here is that you need to follow certain regulation for temperature of wash water used for washing. Otherwise, if the water gets contaminated because of the organisms present on the shell eggs, and if you do not follow this temperature, then the contaminated water will go inside of the shell egg, and that would defeat the purpose of washing. Moving on to a little bit about structure, more specifically, I'm going to focus on cuticle. If you see these openings, these are called pores. And when the egg is laid, the cuticle covers these pores. Thus, the cuticle excludes the egg from dust accumulation as well as bacterial penetration. So, and also the cuticle has proteins that have antimicrobial properties against gram-positive and gram-negative bacteria. Now, the egg washing steps that I showed you in the previous slide and the chemicals that I used actually cause damage to this cuticle and thus increases the risk of bacterial penetration. So that brings me to egg washing debate, where some countries do wash eggs, like United States, but some countries do not wash eggs with the intent of preserving that cuticle or keeping that cuticle intact so that they can reduce the risk of bacterial penetration inside the shell eggs. So let's do a quick trivia here. You just have to shout yes or no when I say the name of the country and just guess whether that country washes the eggs or not. So feel free to unmute yourself and just give me an answer. For USA, I already gave you an answer. It's a yes. Let's see. United Kingdom.
Yes.
It's a no.
Ah!
China.
No.
Correct. Japan.
Yes.
Yes.
That's correct. Good. India.
No.
We do not wash eggs. Yes. Australia.
Yes.
That's correct. Germany.
Yes.
Germany did not wash eggs. Canada.
Yes.
Correct. So you saw that there is no global consensus in the egg washing regulations, and the countries that do not wash eggs, they some of them do not even refrigerate. So again, there is no storage consensus as well for the eggs. So that's what I am exploring. It's time to explore new effective methods to eliminate salmonella, and at the same time, if we can keep the cuticle intact with that method, then it would be probably everybody would follow the same method eventually. So I will share some of the methods that are currently being explored and then move on to my research project. One of the method that is out in the market right now is, if you see these eggs with a P, that means these are pasteurized shell eggs. So this is intended to eliminate salmonella or cause a 5 log reduction of salmonella even inside of the shell egg. Research has shown that cuticle will be removed because of thermal treatments, but now with these eggs we do not have to worry about salmonella because now you don't have it outside and inside of shell egg. However, there is a drawback that there will be egg white denaturation and hence you will not get a good foam formation. So these kind of eggs are not useful in dessert or baked dishes. So these eggs are mostly served in high risk populations and healthcare facilities, and you will rarely find them in grocery stores. Like less than 1% of shell eggs are pasteurized in US. This is something which I wanted to share because I wanted to show you what is apart from what we generally buy, what is out in the market. Besides, some other methods that are currently being explored and I have listed here is microwave. Microwave is also in the direction of pasteurization, where they have targeted a reduction of 5 log in the inside of shell egg. Um, Ultraviolet research is done using 255 nanometer wavelength. Pulse light, where you would use high intensity light and deliver in duration short pulses. So, and then infrared is another method that is being explored, and that is picture here depicting an infrared cabinet where you have different lamps and they would emit the radiation. Now, UV, pulse light, and infrared, all of these, they are effective in microbial elimination and they do not damage the cuticle. However, there is no mechanism where we can remove the dirt from these eggs. So that is something which could be a drawback, or it may have to be applied after removing the dirt. Another method that is explored is green coating. That is, they have used FDA approved or GRAS approved materials, and they just cover after the washing steps, they just dip the egg in this green coating. So think of it that now if the cuticle is damaged, this green coating can act as a cuticle. However, you have to go through these washing steps and then apply this green coating to washing steps to remove the dirt. So I'm going to introduce you to plasma and talk a little bit more about it in the next few slides. So plasma is a fourth state of matter. That is, if you provide high energy to gas or air, the reactive species of free radicals that are formed are in a bubble called plasma. And you can generate cold plasma at less than 60 degrees Celsius. Few years ago, you would require vacuum conditions to generate this plasma, but now it can be produced at atmospheric pressure. In my lab, I am producing or making plasma activated water, where I expose water to this plasma. So the reactive species that are formed in plasma get transferred to water, and this changes the chemistry of water. These reactive species are known to have antimicrobial effects. And our hypothesis is that there are no known harmful chemical residues that are left after plasma treatment. And previous studies have shown that plasma activated water, or I'll call it as PAW, does not damage the cuticle layer of shell eggs. And thus, we hypothesize that this would increase the shelf life of eggs. So, just to give you a quick idea about my PhD research project, I am using this plasma activated water, washing eggs with it, and also comparing conventional sanitizers like chlorine and quaternary ammonia for microbial inactivation and quality of eggs. Today, I'm going to talk more specifically about plasma activated water optimization and characterization, which you'll get to know in a minute. What does that mean? So this is how we are generating plasma in the lab. So you see, this is plasma jet, and this is a rotating nozzle, and it distributes plasma evenly in the beaker. And we have this water being treated. Now, some of the variables that can be adjusted in the lab, I took those and thought, how can I make it more efficient? How can I increase the efficacy of PAW so that we can make the most use of this technology? So what I did is, this distance between nozzle and water can be adjusted. The volume of water can also be changed, and the time the water is being treated with plasma can also be changed. So, all these three variables I took into consideration and came up with three levels for each. So, for time, I decided between 5, 10, and 15, volume between 250 ml and 450 ml, and distance 4.5 centimeter to 8.5 centimeter. Based on this time, volume, and distance, if I perform a full factorial design, I would have to perform 81 experiments based on all these combinations. But instead, I used a statistical experimental design called box-Benkin design that would reduce these combinations to 15 experiments and still help us predict the efficacy of PAW. So after those 15 combinations were generated, for each combination, I performed physicochemical analysis of PAW, that is pH, electrical conductivity, oxidation reduction potential, nitrite and nitrate. I'm listing these out because this is what where the chemistry of water changes because of plasma treatment, and these are responsible for antimicrobial activity. Besides, I also did a microbial inactivation study for those 15 combinations using planktonic cells of Salmonella typhimurium. So just to give a quick idea about the results from optimization study, based on the 15 combinations, 2 combinations gave me the highest reduction of approximately 6 log CFU per ml for Salmonella typhimurium. So moving forward, I used these 2 combinations for my future studies. Now comes the main application part for egg washing. So I'm currently inoculating eggs with different microorganisms, and we have built this spray washer in our lab that can mimic the commercial egg washing system. And I'm going to show you the video. Yes. So it can accommodate 3 eggs at a time, and we can also adjust the pressure as needed based on the coverage of the nozzle for egg washing. So currently, I'm testing different paw washing times required to inactivate Salmonella on the surface of shell eggs. I'm testing from 10 seconds to 3 minutes to see what would be the best time we can use for washing. However, another aspect or another challenge here was in lab, we just generate or pour with 250 or 350 ml volumes of water. But I need large volumes of water for the spray washer system that I just showed you. So just to have larger volumes, I did a study where I created three batches of pour separately and then combined them in a beaker, and I analyze the physicochemical parameters to see if combination of three batches separately and then combining in the beaker and also storing that beaker for a while, how would that change the properties of PAW, including the inactivation efficacy. So based on the results, just to quickly show you how microbial reduction was affected, it was not actually. So when you compare the single batch, a small batch of PAW with large batches of PAW, that is the combined batches of PAW, there was no change in microbial inactivation efficacy. So the results were in favor that we could actually scale up the PAW by combining small batches, and then I could use it for my spray washer systems. So just to conclude this presentation, new egg washing methods are needed to preserve cuticle and mitigate salmonella recalls from what you saw from initial literature background. However, there are challenges associated with new methods and technology, like scaling up the new technology and regulatory approval. Some of the challenges that I see would be for scaling up plasma or plasma activated water would be, for example, energy. So as I mentioned earlier, you need to provide high energy to air or gas, and that's how you would have plasma. So what would be that high energy number on a commercial scale? How much energy would be needed so you can run a full production line for a long time? Then another challenge would be electrode material. You need to have an electrode material that does not cause rust because you're working in a food environment. Gas chemistry, meaning I am using air, so I don't need special arrangement for any type of gases, but there are studies that have used helium or nitrogen gas, and that would, based on that, it would change the chemistry of PAW. And you also need to maintain those gas cylinders accordingly, and that would be can be an additional maintenance requirement in the commercial level. And gas distribution, meaning you saw the nozzle that distributes the plasma evenly in the beaker. Now on a commercial level, if it's large volumes, you probably need maybe a broader nozzle or some kind of system that can distribute plasma evenly when it comes into contact with water. And reactor geometry, meaning there are different types of plasma equipment designs currently being researched, and which one to choose moving forward depends all on your application. So it would not be that this plasma is fixed for all the food products. That would not be the case. And finally, even myself, I did not know what does it mean when we want to differentiate different types of eggs that are available in the market. So I always refer to Egg Nutrition Center from American Egg Board, and they have this very cool infographic which lays out clearly the difference between different types of eggs. And this was just a fun fact. They have many more educational handouts and materials with respect to egg recipes, egg nutrition facts, and egg safety. So you should definitely check those out whenever you have questions about eggs. And I would like to thank my team at North Carolina State University and professionals from the industry who have helped me in my career so far, and also with the research project and today's presentation. And thank you very much, Cindy, for inviting me today. This was a really good audience, and I really enjoyed presenting here. So I am open to any questions.
There was one question in the chat. What is the shelf life of unrefrigerated eggs?
That's a good question. I will have to go back to those countries and check their regulations. But so when I am originally from India and we did not refrigerate our eggs, so we used to consume within 1 to 2 weeks. So I don't remember leaving them out more than 2 weeks. But yeah, I'll have to check their regulations and see what is the shelf life.
Okay. Let's not be shy with asking questions today, people.
I have a question.
Yeah.
So what's the cost of this particular treatment? How much does it add to the cost of eggs? Because eggs are usually like the cheapest protein, right, for many people. So
Correct.
what would this add? And keep in mind the equipment that you're talking about. So can some small processor adopt it?
Yeah, that's a good question. So, first about the cost, I'm still working on the analysis. Like I am, even on a lab scale, we are still working on the numbers because the equipment itself is very expensive. And after that investment, the electricity needed, the electrodes needed for it, the maintenance of the electrodes for plasma generation, all of that comes into picture. So considering all of that, maybe for a small processor at this point, it may not be cost benefit, but again, in United States, very small processors do not wash eggs. So washing is mostly for large processors. So it's one of my objective to compare the egg washing cost using chlorine and quart and potassium hydroxide, and how would it affect if we put this plasma system into a large processing facility. So to answer your point, I do not have the exact numbers yet, but I see it that it may increase the cost because of the energy requirements.
You've got a question.
Oh, should I check the chat?
Sonny, go ahead.
Hi, hi, Urvi. Thank you for the great presentation. I just have one question about the Salmonella strain that you use. You chosen to use Typhimurium.
Right.
Is there a reason for that? Because I remember in the previous slides you showed that I think it's Salmonella enteritidis is the most common strain in egg contamination. So is there a reason why not using the enteritidis?
Yeah. So currently, I was using a virulent strain and hence Salmonella typhimurium, but I have also done studies using Salmonella enteritidis, PT30. I did not show that in this slide. And that I have used it for planktonic cells against paw. And my next step is to inoculate those in on eggs and then do it. So for enteritis, we need to have a biosafety level 2, and that's what I was arranging meanwhile while I was performing studies on a virulent strain.
Okay, thank you.
Any other questions? Britt, did you have a question?
Yeah, I do. Urvi, this was really fabulous. Congratulations on your work. I was thinking a little bit about just some of the questions, and one having to do with, really implementation and the cost of that.
Yeah.
So then I was thinking, well, is there other applications for this technology in the sense of paw, right? So in addition to eggs, can you see this being applied to other
Yes.
commodities or, other things that need some help?
Yes, definitely. I think fresh produce for sure. And we are already in our lab investigating different types of fresh produce like spinach, lettuce, and not just paw. My master's thesis was on a direct plasma application on kale leaves, and that also showed a good reduction in microbial inactivation. So if this technology becomes a success with regulatory approval and cost challenges, then yes, I would see it applied in fresh produce very frequently.
Mhm, mhm.
So I have a question. What makes this process so expensive? Why is the addition of plasma to water such an expensive deal? Why can't we make it cheaply?
So one, I think the energy, so we require 290, currently in our lab, we are using 290 volts. So that's a very high energy requirement. So that would be one. And second, the design of the equipment and the electrodes and the maintenance of those, that would be some other cost. Besides that, now if you compare, let's say HPP, high pressure processing, it took so many years, like 30 years, to at least get onto a commercial level. So this would also take that much time, just because the equipment design that we have right now are on a lab scale. So creating a design that can accommodate large volumes of water, that may also take time. So that's
30 years.
yes, from what I know from my professor, because advisor, she worked in HPP. Yeah.
Britt, you should have somebody in your lab coming up with, little in-home bats or little cottage industry bats, because if it works on kale, our produce sector would really benefit immensely.
Correct.
I can't believe that it would take that.
Do we have any more questions? So I'm not sure who has control of the slide, but if you want to pull the slide down, we can see everybody's face.
Yeah,
Oh,
I was
perfect.
trying.
Oh, yeah. Oh, okay. Thanks, Cindy. Although we're seeing a lot of names, would love to see faces. Any other questions?
I thought the one comment that Guy had shared with us, he said that the US didn't even start refrigerating eggs until the early 1970s. So what was the reason from not refrigerating them to having them be refrigerated?
Oh, that's interesting. Maybe they started washing, and that's when the washing would require refrigeration, because now the cuticle is damaged. So that actually reduces the shelf life of the eggs. So refrigeration would increase the shelf life. I don't know when did they start washing eggs, but if that's the number 1970s, then maybe they started washing at that time.
The answer for that one?
So somebody says Stephen Walker can answer this. Who's Stephen Walker?
He's one of the FDA employees, but he's not on the call, I don't think.
Okay.
We can ask him though.
Well, eggs have been a very important part of our culture. It's a food that's also iconic. So a few years ago, I think 8 or 9 years ago to be precise, and there was a local food editor who got a contract to write a book on the culinary history of eggs. But she unfortunately passed away in the middle of the book. Mm-hmm. So I got the job of writing that book and completing it, but I did it without getting my name on it. And it's called The Culinary History of Eggs, Global History of Eggs. And there was a lot of information, but nothing about this part of it. So this is amazing, really nice. But eggs are such an integral part of so many of our cultural things, particularly in the West, right? Fascinating presentation.
Thank you so much, Urvi, for this wonderful presentation. I do have a question. Did you look into, I know you looked up on cuticle, like there was no damage to the cuticle with this technology. Did you look into any internal contents of the egg, like nutritional composition wise? Was there any impact? I believe this is a mild treatment, not very harsh. Any effect on the functional properties alongside?
That's a good question. It's a future research of my project to look at the nutrient component. But from the internal component standpoint, I'm also going to look into yolk height, albumin height, that could indicate the freshness of the egg, and pH as well.
Okay. Thank you.
Any other questions before we wrap up today's seminar?
Well, I'm just going to make the comment that I think that this was wonderful. And I think I really like the idea of bringing young investigators into our seminar series. You did a phenomenal job, Urvi. So again, I'll just say congratulations. And I think that you made us start thinking about why not have, young investigators investigators, future leaders be, have the limelight in these seminars. It was very informative. And so thank you so much.
Thank you.
Yes, thank you very much for an outstanding presentation, and to everybody who participated today.
Wonderful.
All right. Have a great day. Thank you.
Bye, everyone.
Thank you, everyone. Have a good day.
Okay.